Welcome dear students. Today we are going to discuss a very important industrial process that is called as the Fischer Tropsch process, or in short form FT process. My dear students, this process was introduced by two German chemists Franz Fischer and Hans Tropsch in 1925 to convert the gaseous fuels into the liquid hydrocarbons. And the liquid hydrocarbons produced by this process, they were used in World War II as a fuel for the warfare. The reactants in this process, that is a mixture of carbon monoxide and hydrogen gas, which is called as synthesis gas, or in short form syn gas. And the syn gas is produced by the solid fuels like coal by a process that is called as the gasification. So the basic raw material are the solid fuels like coal, biomass, that are converted to syn gases through a process of gasification, and then this syn gas, which is a mixture of carbon monoxide and hydrogen, it acts as reactant in the FT process. The products are liquid hydrocarbons. These liquid hydrocarbons may be alkanes, and the most important product, that is the gasoline, in common language it is called as petrol. The conditions are temperature from 150 to 300 degrees Celsius. If you will use very high temperature, then the product obtained, that will be wax. But if you will use temperature in this range, then the product obtained, that will be basically gasoline or other low molecular mass olefins. But keep in mind that some oxygenated products like carboxylic acid, they can also be produced as the byproduct. The pressure can be from normal to very high depending upon the nature of the products you want to produce. The catalyst is usually a metal. Iron, cobalt, nickel and ruthenium are the options. Cobalt and ruthenium both are very expensive, so they will make the process uneconomical. The nickel, if that is used as a catalyst in FT process, it produces large amount of the methane as the byproduct, so it is not a suitable catalyst. The most suitable catalyst with respect to its cost, that is iron, and iron is used as a catalyst, and the oxide of the potassium is used as a promoter in this process. Iron will make the process faster and the promoter will make the iron faster, so that will improve the efficiency of the iron actually. Now, this FT process is an example of heterogeneous catalysis. Heterogeneous catalysis is the catalysis in which the reactants and catalysts are in different physical states. And in this process, the reactants are the gases and the catalyst is solid. So they are in different physical state. That will be an example of the heterogeneous catalysis. Now let's see what's the general equation of this process. The n moles of the carbon monoxide, they will react with 2n plus 1 mole of hydrogen. The hydrogen is used in an excess quantity, so that will be excess reactant, and carbon monoxide, because of its smaller amount, that will be acting as a limiting reactant. They will react together under all these conditions that we have already discussed, and they will produce alkane. These alkanes are the liquid alkanes, and the most important one is the octane, that is the formula of the gasoline. Water and heat will be produced because this process is exothermic, so nearly around about 165 kilojoule per mole heat is produced. The N here, that ranges from 10 to 20, but keep in mind that the N should not be equal to 1, because if N will be 1, then methane will be the major product, and that is not our desired product. So N is not 1 in this process. It is an example of condensation polymerization reaction of carbon monoxide. Condensation polymerization means that the carbon monoxide along with hydrogen is condensed, and then the polymers in the form of large molecular mass liquid hydrocarbons are produced. My dear students, this one is the equation in which we have taken N8. So 8 moles of carbon monoxide, they will react with 17 moles of hydrogen at 150 to 300 degrees Celsius in the presence of catalyst. Octane is the product. Gasoline is actually a mixture of the alkanes, but the octane is present in maximum percentage in the gasoline. So whenever C8H18 is written, it is considered as the molecular formula of the gasoline, because octane is the major component of the gasoline. Water is produced. So basically in this process, the syngas or the gaseous reactants, they will be converted into the gasoline, which is the most important fuel commonly used in the society. But this process was once very important. Nowadays there are so many alternate processes of producing the gasoline at commercial level. Just as an example, that is the fractional distillation of the petroleum. Fractional distillation of petroleum nowadays, that is the main process through which the gasoline is produced, as it is more economical as compared to this FT process. Now, my dear students, what is the role of hydrogen in this process? As you know, carbon monoxide, it is a polar molecule with a very strong triple bond. So, to break the triple bond, which is polar in case of carbon monoxide, that will be a challenge. So, this triple bond of the carbon monoxide is broken down in the presence of hydrogen or with the help of hydrogen. That is why you will say that the hydrogenolysis of this triple bond takes place. And my dear students, this one is just simple diagram that will show the mechanism of this process. This is metal M, which is a catalyst basically, and in most cases that is iron. First of all, the carbon monoxide gets adsorbed on the surface of the metal, and the splitting of the triple bond takes place. So the first step is the adsorption of carbon monoxide and splitting of its bond. Then in second step, the hydrogen will get adsorbed and its bond will be splitted. The hydrogen will react with carbon and that will be changed to methylene, and this methylene will be adsorbed on the surface of the metal. Similarly, the hydrogen will react with oxygen to produce water, and the heat is released in this process. Now this CH2, which is methylene, that will act as a small molecule, small unit, and it will further react with the reactants to produce the large molecular mass linear liquid hydrocarbons. So in this way, the gases, they are converted to the liquid hydrocarbons. Now, my dear students, this one is a very simple flow sheet diagram in front of you. Flow sheet diagram is the diagram which shows all the steps involved in an industrial process simply in a correct sequence on paper. So this one is the flow sheet diagram. In the first two chambers, the purification of the reactant gases takes place. In the first chamber, the reactant gases are introduced, and these are the shelves which have Fe2O3, and Fe2O3 will remove the impurities from these gases. Then in second chamber, in the shelves, Fe2O3 with sodium carbonate is present. They will absorb the sulfur and its compounds out of the reacting gases. So the removal of sulfur and its compound will take place in this step. These first two chambers, they are basically for the purification of the reactant gases. Now the purified gases that will move next to the compressor, which will compress the gases from 5 to 25 atm. Now the compressed gases will move to the catalyst tower, where there is a bed of the catalyst and the heat is provided. Iron will act as catalyst, K2O will act as promoter. Now the purified compressed gases, they will react in this catalyst chamber and they will produce the products. Next, these gases, they will move to the cooling chamber because the process was exothermic. So heat is released that will make the gases hotter, and in this cooling chamber, this cooler will remove that heat from the gases or the products and they will cool down. And finally, in the fractionating column, now the different liquid fractions will be collected. The most important fraction will be gasoline, and there will be some other fractions like heavy oil, waxes, and these heavy oil and waxes through cracking is another process, they are converted to the gasoline. So you can conclude that during this FT process, the main thing, the main concept is to convert the gaseous fuels into the liquid hydrocarbons, and the most important liquid hydrocarbon, that is gasoline. So that was about the Fischer Tropsch process. I hope so this lecture will be very understandable for you people. In case you find any problem, you can ask in the comment section. Till then, take care.